Continuing with the same calculation, what we need to do in the next step, we need to transform these frequencies to probabilities, and we denote it as the probabilities of x bar. What we need to do, since the sum of the frequency is 25 and it is an odd number, so better to leave this time the probabilities as a fraction, because what we may face as a problem that sometimes when we divide any number by an odd number, or for instance 1 on 25 may give us an answer that will have a recurring decimal places, and we are bound to round off this number if we transform it to decimal numbers. So better to avoid transforming these fractions into decimal numbers, because to deal with the fractions, when the divisor is the same value or denominator is the same value, it's not difficult, it's very easy to deal with. So this is how I am transforming these probabilities and leaving it in fractions for this reason. So what we get as the total or the sum of the column is, or the sum of probability of x bar is 1. That is in line with the basic axiom of probability, that sum of all the probabilities of any random variable x, or over here in our case x bar, is 1. Now what we need to do in the next step, we need to, as usual, take the product of each value of x bar with its associated probability. And what we do, simply 80 times 1 gives us 80, then 81 times 2 gives us 162, so that's 162 on 25, then 82 on 25, then this is 5, 2 times 5 is 10, 2 times 2 is 4, and 1 5, and 2 times 8 is 16, so 165 on 25, then was 167 on 25, then 2 times 4 is 8, and 2 times 8 is 16, so that's 168 on 25, then 85 times 5 is how much? 85 times 5 is 425, so 425 on 25, then 86 times 2 is 172, then 86.5 times 2 is 173 on 25, then this would be 175 on 25, then 88 on 25, then 89 times 2 is 178 on 25, and then 90 on 25. Now adding the numerators, we must be getting the answer as 2125 on 25. This is what you can check on your part. Now to move to the next calculation or working, we need to raise each value of x bar to square and then multiply it by associated probability. What we do, 80 times 80 we can take it as, so that's 6400 on 25. What we can do, simply we can multiply the numerator of this value again with the value of given value of x bar or associated value of x bar. So now 162 times 81 gives us 13122 on 25. Then we have 82 squared is 6724 on 25. Then 165 times 82.5 again. So 13612.5 on 25. Then we have 84, 83 times 83.5 times 167. That's 13944.5 on 25. Then we have 168 times 84. That's 14112 on 25. Then we have 425 times 85. That's 36125 on 25. Then we have 172 times 86. That's 414, and then times 2 as well. Yeah, this is already multiplied by 2. So 172 times 86 gives us 14792 on 25. Then 173 times 86.5 gives us 14964.5 on 25. Then we have 175 times 87.5, that gives us 15312.5 on 25. Then we have 88 squared, that is 7744 on 25. Then we have 178 times 89, that's 15842 on 25. And the last one is 90 squared is 8100. So 8100 on 25. Now we need to add them all. And I would tell you what should be the numerator of this number. The sum should be 180795 on 25. So again, using the same formula for the mean of the sample mean, that is equal to summation x bar times p of x bar, that we are getting as 2125 on 25, and 2125 on 25 gives us the answer as 85. So again we have proved that mean of the sample means is equal to population mean. Similarly, if we consider the formula for sigma of x bar squared, this we can compute as the sum of the product of x bar squared and probability of x bar, take away sum of x bar times probability of x bar whole squared. Now substituting this factor over here, the answer is A180795 on 25. Take away this answer, we have worked out already as 85, so that's 85 squared. And now what we get when we divide 180795 by 25, we get 7231.5 0.8. Take away 84 squared is 7225, and we get the variance as 6.8. So this is how we get the answer for the variance for sample size of 2.